you are aware that here we have Cartesian coordinate system. So in case of Cartesian coordinate system, what are the variables? What are the parameters that's going to change here? X, Y, and Z. Okay. So now it has unit vectors AX along the x-axis, AY along the y-axis, AZ along the z-axis. So finally here, this differential volume is considered here. Okay. So for that, dimensions are dx, dy, dz. So finally, the differential volume you can write easily, that is the dv equal to dx, dy, dz. Similarly, differential length or differential displacement dl we can write easily, that is dx ax plus dy ay plus dz az. Now we have to see the differential surface area. That is important here. So here we have different surface. So if you see that, you will get three unique surface here. On the basis of that, we can have differential area. Suppose, for example, if you take the one surface that is looking there, we have A, B, C, D. From the diagram we are writing, okay? This one is what? A, B, C, D, this part. This A, B, C, D. Now for this, what will be the dimensions here? What is the length of the DC? DC will be dy. And what is the length of BC? BC is the dz. So area of this is what? Dy into dz, whereas the area vector, which will be perpendicular to that plane ABCD, that surface, will be pointing outwards. So finally, that will come like AX. So finally here ds we can write dy, dz, and unit vector is the AX. Similarly, we have another surface. Okay. So now suppose we are going to take here B, C. So that you can correlate this one with diagram. So this is our B, C, R, Q. So for BCRQ, what is the dimension? CR is what? dx. RQ is what? dz. So finally, area of this is the dx, dz. And the normal to this is what? Outwards. So that is here AY. So finally, differential area here due to this surface dx, dz, and AY. Now one surface will be opposite of this. That is the opposite of this is what? Which one? If you look here, that is ADSP. So area will be same, but unit vector will be minus AY. Similarly, opposite of this side, you will observe that you have PSRQ. So area will be same, that unit vector will be here minus AX, and in this case we have minus AY. So now one more different surface we have here. So that is this part we have taken. So we'll take one top one. So top and bottom both opposite is same. So one top one we are going to take. So that, what is the name of that one? Can observe here ABQP. So for ABQP, if you are going to see here, what is the dimension? So AB is same as the dy. Yes. And what is the BQ? BQ same as the dx. And what will be the area vector that is normal to this is the AZ. So finally here ds is what? dx, dy. Area, that vector is what? Az. And the surface which is opposite to this, we have dcrs. So for dcrs, area will remain same, but that area vector which will become the minus az. So this is the thing what you are seeing in case of Cartesian coordinates. Similarly, we have a discussion about another coordinate system, that is the cylindrical coordinate system. So in case of cylindrical coordinate system, we have three parameters. Like in case of Cartesian, you have seen x, y, z. So here we have rho, phi, z. Okay. So here range of rho is going to change from the 0 to infinity, and this phi is going to change from the 0 to 2 pi. Okay. And what about z? Z is going to change from the negative infinity to positive infinity. In the Cartesian coordinates, x, y, z, all three were having range same, minus infinity to plus infinity. So now here, if you consider some point here, okay, at this surface of the cylinder, so that a rho vector is the radially outwards, a phi is in this direction anti-clockwise, a z is the perpendicular to this. So like this three unit vector we have here. Now again, here differential volume is considered. So for that we need to understand what can be the sides of this differential volume. Okay. So this is the perpendicular, that is the dz. It is along the z, so it is the dz. This is the radially, okay, so along the direction of the radius, that is the rho, that is the differential is the d rho. Only we have to find what is the value of this arc. So that arc value from the basics of the circle you will have from your school days. What is the value? So this angle is what? D phi. Okay. So this same thing what we have here in this plane, that is projected there. And this length is rho. So what is the length of this arc? That is the rho d phi. Okay. So now three dimension here you understood. So we have dimensions are here d rho, rho d phi and dz. So now easily you can write the volume, differential volume, and easily you can write the differential displacement also here. Only little bit tricky is about differential surface area. So differential length we are going to write here. Okay. So we have d rho along the arrow unit vector plus rho d phi is along the a phi plus dz along the az. So it is important to find the dimension of that differential volume. Then easily we can write, okay, along that direction. Similarly, differential volume, what we'll get? Just product of this. All three are being multiplied here. So we'll get rho, d rho, d phi, dz. That is the differential volume. Now it is about what will be the differential surface area. So now different dimensions you are going to take. Suppose for example, first we are talking about this part. So this is the curve, okay? So that name is here. If you correlate with diagram, this is the PQ BA. So what is the dimension? See the diagram from here. Already we have seen YQB is the rho d phi. And what is the AB? Is along the z axis, so dz. What about the vectors? Unit vector perpendicular outside this, that is what? A rho. So finally, surface area is what here? Rho d phi dz, area vector, that is the A rho. Similarly, we'll take the another surface. Suppose we are taking the top one. So this top one, how it is going to look here? So for that, we have shape in this format. Okay. So finally, if you try to find, so this length is again rho d phi. And this length is what? D rho. So what will be the area vectors? So that will be perpendicular to this. Okay. So that is what here, what we are going to get? AZ. So finally area is rho d phi d rho along the AZ. And third shape, you will take the this one, side one. Okay. So that if you will observe, it is going to be in the format like this. Okay, so that is the back side we are drawing from there. So this name is here from the diagram CBAD. CBAD. So for the CBAD again, what is the dimension here? AB is what? DZ. AD is what? D rho. So now in this, that area vectors, so finally it will be along the A phi. So that A phi will be perpendicular to this. Okay. So that will be the A phi. So that why we'll write D rho dz A phi. So this A phi is here inside the paper. So now phi is changing in the anti-clockwise. So that's why inside the paper A phi is the positive, outside it will be the negative. So whatever dimensions we have taken for each and every one, opposite surface area is there. For that only vector will change. Like AZ will become minus AZ. A rho will become minus A rho. A phi will become minus A phi. So like this, we are able to write these three basic parameters. Okay. Next, we have another one that we call a spherical coordinate system. So in the spherical coordinate system, again, we'll have a similar discussion. So can you remind what is the variables here? In case of spherical coordinates, we have r, theta, phi. So this r is going to range from the 0 to infinity. And theta is already we have seen. This one you are going to make here with this radius. Okay. This angle is theta. So that is going to change from where to where? 0 to pi. And a spherical coordinate, when you are rotating this one, complete one cycle, this bow is going to form the that is the sphere. So that's why phi is going to change from 0 to 2 pi. Now again, if you see that dimensions, how we are getting the dimension of this differential volume here. And if you're trying to consider some point P, suppose at this, okay. So here we can represent all unit vector at this point. So if you try to join from here to here, okay. So this will be the radially outwards, that will be the AR. And along this, theta is changing, right? So this will be the A theta. And along this, phi is changing. So this will be the A phi. Like this, we have AR, A theta, A phi. Now for this differential volume, what is the dimension that you try to find here? So this arc, same formula we are applying here. So if you see in this format separately, so this arc length, this radius is r, this is the d theta. So that's why this length is r d theta. Similarly, we'll look for the another dimension about this dimension. What will be the length of that? So finally, for that, if you are trying to conclude here, so this is connected to the center. So this angle, differential angle is here, d phi. Okay, same thing you can project here in this plane. So easily you can see that this angle is the d phi. And radius, if you see that in this case, finally, here this part, when you are going to project here, so for this we have this R. If you project along the z-axis, you will get here R cos theta. If you project along this xy plane, what will get here? R sin theta. So this is going to be the R sin theta. Okay. So this R sin theta will be the radius. So finally, what will be the length of this arc? It will become R sin theta d phi. So like this, we have three dimensions, three lengths we are able to get, and this is along this differential radially outwards. So that differential part is the dr. So finally, here we have three dimensions, that is the dr. Then another we have r d theta, and third one is the r sin theta d phi. So now differential displacement dl you can write easily. So that is the dr ar plus r d theta a theta plus r sin theta d phi a phi. Similarly, differential volume we can write easily. Okay. So differential volume, again, product of all these things. So dr r d theta r sin theta d phi. Now if we rearrange this, what we are going to get here? R square sin theta dr d theta d phi. This is the differential volume. Similarly, we can find the differential surface. Okay. So one example we are going to take for this case. This surface is like this. So this length is what? R sin theta d phi. This length is what? R d theta. So finally, area vector is what? Radially outwards. Okay, so that will be here AR. So this ds will be written as R d theta into R sin theta and d phi along the unit vector AR. So finally, if you arrange here, R square sin theta d phi. This is the d phi and AR. Similarly, we can write the another one. Okay. So like this, the three expression we are going to get here, differential surface here. Okay. So another what we have here, another you will get here dr r d theta a phi, and one more what we will get here dr r sin theta d phi along this a theta. Okay. So like this, we are able to find the differential length, volume, all these things. Okay. In all three coordinates. Thank you.